In project management, mastering time management is crucial for success. The backward pass technique optimizes project schedules by calculating the latest possible start and finish times for each activity. This method works backward from the project's end date, identifying scheduling flexibility and potential bottlenecks. It complements the forward pass, which determines the earliest start and finish times. By understanding both passes, project managers can make informed decisions about resource allocation and task prioritization. Imagine a construction project with a fixed deadline. The backward pass starts from the completion date and works backward through each phase. This approach helps identify potential delays and ensures no activity encroaches upon the critical path. Understanding the backward pass enhances decision-making, optimizes resources, and ensures timely project completion. Before diving into the backward pass, it's essential to grasp project schedules. A project schedule is more than just a timeline. It's a comprehensive plan that outlines the sequence of activities, their dependencies, and the time required to complete each task. A project schedule outlines activities, dependencies, and durations, serving as a roadmap. This roadmap helps project managers and teams visualize the entire project from start to finish, ensuring that every task is accounted for and properly sequenced. The Gantt chart is a prevalent method, depicting activities on the vertical axis and time on the horizontal axis. This visual representation makes it easy to see the project's progress at a glance and identify any potential bottlenecks or delays. Each activity is represented by a bar, indicating its duration and start-finish times. The length of the bar corresponds to the time required to complete the task, while the position of the bar shows when the task is scheduled to begin and end. Gantt charts provide a clear overview of the project timeline and relationships between activities. By showing how tasks overlap and depend on one another, Gantt charts help project managers allocate resources efficiently and ensure that the project stays on track. Dependencies define the order of activities. Some must be completed before others can start. Understanding these dependencies is crucial for creating a realistic and achievable project schedule. For example, in software development, coding can't begin until design is finalized. This dependency ensures that the coding team has a clear and complete design to work from, reducing the risk of errors and rework. Accurate dependencies and durations create a realistic project schedule, guiding the team towards the goal. Regularly updating the schedule to reflect actual progress and any changes in dependencies or durations is essential for keeping the project on track. A well-structured schedule facilitates coordination, communication, and project success. When everyone on the team understands the schedule and their role within it, they can work together more effectively to achieve the project's objectives. Understanding project schedules is fundamental for effective project management. By mastering the art of scheduling, project managers can ensure that their projects are completed on time, within budget, and to the desired quality standards. This knowledge empowers teams to anticipate challenges, allocate resources wisely, and maintain momentum throughout the project lifecycle. The Critical Path Method, CPM, estimates project duration and identifies critical activities. CPM helps prioritize tasks, allocate resources, and mitigate delays. The critical path is the longest sequence of activities, determining the shortest project duration. Delays in critical path activities impact the overall project completion time. Network diagrams like PERT or PDM charts visually represent activities and dependencies. Calculating earliest and latest start-finish times reveals the critical path with zero float. Understanding CPM is crucial for effective project scheduling and analysis. Before the backward pass, understand its counterpart, the forward pass. The forward pass determines the earliest start and finish times for each activity. It begins with the project's start date and progresses chronologically. For example, in a construction project, laying the foundation depends on completing the excavation. The forward pass helps identify the earliest possible project completion date. It also highlights potential resource conflicts and allows for adjustments. The forward pass sets the stage for the backward pass, revealing the latest permissible timelines. Understanding both passes provides a comprehensive view of the project schedule. The backward pass offers a retrospective view, starting from the project's end date. It determines the latest possible start and finish times for each activity. This reverse journey reveals schedule flexibility and critical timelines, For example, in a construction project, the painting activity's latest start time is calculated by subtracting its duration from the project deadline. The backward pass continues until all activities' latest start and finish times are determined. It identifies the critical path where delays directly impact the project's completion date. Understanding the backward pass helps prioritize efforts and allocate resources strategically. Calculating the latest start and finish times is core to the backward pass. To determine the latest start time, LST, subtract the activity's duration from its latest finish time, LFT. For example, if an activity's LFT is day 20 and its duration is 5 days, its LST is day 15. The latest finish time, LFT, is constrained by the earliest latest start time, LST, of successor activities. These calculations are performed for each activity, working backward from the project's end date. Understanding these times highlights the critical path and schedule flexibility. Float, or slack, is crucial for understanding schedule flexibility. Float is the time an activity can be delayed without affecting the project's completion date. Total float is the delay time without impacting any successor activity or the project. Free float is the delay time without affecting the earliest start of successor activities. Critical path activities have zero float. Delays here impact the project completion date. Non-critical activities have varying float, providing scheduling flexibility. Understanding float helps in resource allocation, task prioritization, and risk mitigation. Effective float management enhances resource utilization and project completion. Let's illustrate the backward pass with a construction project example. Consider a residential building project with activities like excavation, foundation, framing, roofing, exterior walls, windows and doors, and interior finishing. Assuming a project deadline of 45 days, the backward pass starts from day 45. Subtracting durations, we determine the latest start and finish times for each activity. The critical path might be excavation, foundation, framing, roofing. Interior finishing. These activities have zero float, meaning delays directly impact the project. Activities like exterior walls and windows and doors have some float, allowing scheduling flexibility. The backward pass helps identify the critical path and scheduling flexibility. Project managers can allocate resources and mitigate risks effectively. Understanding the backward pass optimizes the schedule and ensures timely project completion. The backward pass offers significant benefits in project management. It provides accurate project duration estimation by considering potential delays. It identifies the critical path, highlighting activities that impact the project's completion date. The backward pass reveals schedule flexibility, aiding resource allocation and task prioritization. It enhances resource optimization by ensuring critical activities are adequately staffed. The technique improves risk management by identifying potential bottlenecks. Leveraging the backward pass optimizes schedules, mitigates risks, and ensures on-time project completion. Understanding its benefits is crucial for effective project management. The backward pass works best when integrated with other project management techniques. Combining it with the forward pass forms the foundation of the critical path method, CPM. This integration provides a complete picture of the project's schedule and potential risks. Resource leveling adjusts the schedule to address resource constraints. The backward pass helps identify activities with float, allowing for effective resource allocation. Integrating with risk management focuses on critical activities with minimal float. This comprehensive approach ensures accurate schedules, optimized resources, and effective risk mitigation. Integrating the backward pass enhances project scheduling and control. The backward pass is a cornerstone of effective project management. It unveils the critical path and highlights scheduling flexibility. This knowledge empowers project managers to make informed decisions and allocate resources efficiently. The backward pass, combined with the forward pass, forms the backbone of the critical path method. Understanding and integrating the backward pass with other methodologies ensures project success. Mastering the backward pass equips project managers to navigate project complexities and achieve timely completion.